Review for Geometry, Topic 8, Exam, Section 2. Section 2 has 13 questions. And I'm going to tell you right now, Section 2 is very challenging. It has some difficult stuff in there. You definitely need to study and prepare for Section 2. If you show up for Section 2 unprepared, you're going to do awful. I'm telling you right now. Okay, now in Section 2, there are a few questions, about 3 or 4 questions, that are on a chapter that we skipped, okay? But I'm going to go over how to do the questions. It's actually something that's not difficult, all right? So question 1 is about that. It's about density, all right? Density. Question 1 says, in 2020, a city in the United States had a population of about 1.25 million people and covered an area of about 2,000 square kilometers. What was the approximate population density of that city in 2020? All right, so population density is part of that chapter that we didn't cover. Okay, population density is a measurement of population per unit area. It measures how many people are in a unit area. So, for example, let me show you the formula for population density. The formula for population density is the population divided by the area, because population density is measuring how many people are in a given unit area. So for example, in this question, it says there are about 1.25 million people in an area of about 2,000 square kilometers. So that's simple. You're just going to put that into the formula. On the top, you put the population. And the only thing I got to say that you got to understand how to write correctly is how to translate from 1.25 million to understand that means 1,250,000. 1.25 million, you write it this way, 1,250,000. On the test, there's a similar number, so you got to know how to translate from that to that. So I'm going to divide that by the area, which is 2,000 square kilometers. All right, so you just divide those two numbers, and that'll give you the answer, which tells you there's 625 persons per square kilometer. All right, when you divide this, it's telling you that for every square kilometer in this city, there's approximately 625 persons. All right, that's the formula for population density. Again, it's measuring how many people in a given unit area, in this case, per every square kilometer. We're going to have more questions on density and population density later on in section 2. All right. Question number 2. A grain silo is approximately 80% full. A 55-pound sack of grain measures 2 cubic feet. What is the best estimate of the number of bags that can be used to fill all the grain in the silo? Okay, so first of all, a grain silo. This is a grain silo. It's this figure here that's holding grain. All right, it's used to hold grain. It says it's approximately 80% full of grain, and they want to know how many sacks are they going to need to fill up all the grain that is in this silo. All right, they want to know what is the best estimate of the number of bags that can be used to fill all the grain in the silo. All right, so let me lay out step-by-step process of how to find the answer. All right, the first thing we're going to do is find the volume of the cylinder and the volume of the cone that's on the bottom, okay? So first, let's get the volume of the cylinder. The formula for volume of cylinder is the area of the base times the height. The radius is 5 and the height is 14. So when we substitute those numbers, we're going to get the volume of the cylinder is 350 pi cubic feet. Now let's get the volume of the cone. All right, so the volume of a cone, the formula is 1/3 times the area of the base times the height. Again, the radius is 5 and the height of the cone is 12. So when you substitute those numbers, you're going to get the volume of the cone is 100 pi cubic feet. Okay, now let's get the total volume of this composite figure by adding the volume of the cylinder plus the volume of the cone. When we add their volumes together, the total volume is 450 pi cubic feet. However, now, since this grain silo is only 80% full, we got to get 80% of the total volume. All right, so we're going to get 80% of the total volume of this composite figure by multiplying 0.80 times the volume of the composite figure, which is 450 pi. So when I multiply 0.80 times 450 pi, I get 360 pi. And when I multiply 360 times pi, I get that there's that amount of grain, all right? That tells me how much grain is in the grain silo. All right, there's approximately 1,130.97 cubic feet of grain. Okay, now the final step is this. Okay, the final step is we got to divide the amount of grain that we have by the size of each bag. All right, and right here it tells you that each bag is 2 cubic feet. Okay, each bag is 2 cubic feet. So divide the amount of grain, which is 1130.97, by 2 cubic feet, and that gives us approximately 565.5, which when you round it will mean that you need 566 bags to fill all the grain in the silo. That's definitely the problem is totally doable, but you need to look at it ahead of time and make sure you understand all the steps. And just to reiterate, there's actually quite a few problems like this on section 2 where you got to work out a lot of stuff. Question number 3. Marco wants to install a fence around his garden. The garden is rectangular and has an area of 224 square feet. One side of the garden is along the street and is 16 feet long. For this side of the garden, Marco will use fencing that costs $20 per linear foot. For the other 3 sides of the garden, Marco will use fencing that costs $10 per linear foot. What is the total cost of fencing? Okay, so here we have Marco's garden. They give us the area of the garden. It's a rectangle. All right, this side is 16 feet. So first of all, let's find the length of this side, which is the same as this one. All right, by doing the area divided by the length. So 224 divided by 16. All right, when we divide 224 by 16, that'll give us the length of this side, which is 14 feet. Okay, now that we have that, the rest of the problem is pretty easy. All right, it says that for the side of the garden, for this side of the garden, which measures 16 feet, all right, Marco is going to use fencing that costs $20 per linear foot. So that's right here, we're multiplying $20 times 16 feet. Okay, now for the other 3 sides, okay, it says right here, for the other 3 sides of the garden, Marco will use fencing that costs $10 per foot. So we already know that this side is 14. That means this side is also 14. And this side back here is the same as this one. So it's 16 feet. So $10 per square foot for this side plus this side plus this side. 14 plus 16 plus 14. So that's how you would set up the expression. And when you do the distributive property and work that out and simplify it, the total cost of the fencing for Marco's garden is going to be $760. Question number 4. This one I have it split into 4A and 4B. All right. This is not in my review. This is not really a question. It's just make sure you read this and understand it. Okay. It says a cube can be dissected into 2 congruent triangular prisms that each have half the base area of the cube. So the volume of a triangular prism is volume equals area of base times height, where B is the area of its base and H is its height. Okay, let me give you a little clue or an easy way to answer this on the test. Okay, you should know, if you've been doing your homework, you should know that that is the formula to get the volume of a triangular prism. Okay, if you know that, then that's all you need to know to answer this part of the question, okay? Make sure you know the formula to get the volume of a triangular prism. Why am I saying that? Because the other choice will look just like this, but the formula is wrong. All right, so as long as you know the formula to get the volume of a triangular prism, which is this, you'll be good to go. All right, but if you don't know it very well, the other one looks very similar to this. All right, and same advice for this question, 4b. All right, they're both part of the same question. 4b says a cube can be dissected into 6 congruent square pyramids that each have half the height of the cube. So the volume of a square pyramid is volume equals 1/3 area of base times height, where the capital B is the area of its base and H is its height. So look, first of all, I got this picture off the internet. If you see right there in the center, it's kind of hard to visualize, but you have 6 square pyramids here. If you can't see it, like look over here. This I tried to create in PowerPoint. Okay, like there's 2 red ones, 2 blue ones, and 2 black ones. All right. Oh, I think I accidentally put more than 2 black ones, but I think I put an extra one right there. Anyways, pretend there's 6. Kind of messed up there. All right, pretend there's 6 square pyramids here. Okay, they're uniting in the middle and creating this cube. All right, so a cube can be dissected into 6 congruent square pyramids. Okay, and I'm going to give you the same advice that I gave you on 4a. Make sure you know the formula for the volume of a square pyramid, or the volume of a pyramid. It's the same thing, okay? Make sure you know the formula for the volume of a pyramid, which is this. As long as you know that, you'll be able to answer the question. Because the incorrect answer choice will look exactly like this, except with the wrong formula. So just make sure you know the formula for the volume of a pyramid. It's in the review, so I don't see how you could get that wrong, but I'm sure somebody will find a way to mess that up. All right, and again, sorry, I made a little mistake there. It looks like I accidentally put 2 pyramids here when there should be just 1. All right, moving on. Question number 5. A candle maker purchased packaging boxes to ship cylindrical candles to customers. The boxes measure 5 inches by 5 inches by 8 inches. To keep the candles from damaging, foam inserts with a thickness of 1/2 inch are placed between the candle and the inside of the box on all sides. What is the volume of the largest candle that can be shipped out? Okay, so first of all, let me do a little drawing so that we could picture this a little bit better. We have boxes to ship out these cylindrical candles, all right? And the boxes measure, let me change colors here. The boxes measure 5 inches by 5 inches by 8 inches. Okay, now the key to doing this problem is to realize that since they're inserting these foam inserts on all sides with a thickness of 1/2 inch, question number 5. A candle maker purchased packaging boxes to ship cylindrical candles to customers. The boxes measure 5 inches by 5 inches by 8 inches. To keep the candles from damaging, foam inserts with a thickness of 1/2 inch are placed between the candle and the inside of the box on all sides. What is the volume of the largest candle that can be shipped out? Okay, so for this question, let me see if I could draw a little example here that'll help us understand it better. All right. So this is from the bottom, okay? This is our box. Okay, now it says that the box measures 5 inches by 5 inches by 8 inches, okay? But the key to doing this problem is understanding what happens when they add these foam inserts with a thickness of 1/2 inch. Okay, so for example, when you add that foam insert on the top, That's going to reduce the height of the box by 1/2 inch on the top, and when you put it on the bottom, it's going to reduce it by 1/2 inch on the bottom as well, making the height of the box, the height, instead of being, it's supposed to be 8 inches, but because the foam inserts are taking away a 1/2 inch on the top and a 1/2 inch on the bottom, together when you add those two up, that's 1 inch. So the height of the height that's going to be available inside the box is basically going to be 7 inches. All right. All I did is subtract 1 inch from 8 inches. All right. Because of the 1 inch foam insert on the top and on the bottom. It's going to be the same situation on the sides. Okay. The sides are supposed to be 5 inches by 5 inches. Okay. But let me see how I could draw this. If you're going to add foam inserts on the side that are each 1/2 inch, and on the front and on the back as well, that's gonna reduce by 1 inch each of these dimensions. All right, you gotta, if you don't see that, you gotta think about it, because it's kind of hard to draw that. As you can see, I'm having a little bit of a tough time drawing that. All right, I did the height one first because I think it's easier to visualize with the height one. Okay, but if you put those 1/2 inch foam inserts on the two sides and on the front and on the back, all right, on every single side of the box and on the top and on the bottom, all right, it's gonna, since when you add 1/2 plus 1/2, you get 1 inch. It's gonna reduce each of these dimensions by 1 inch. All right, that's the key to understanding this problem. All right, which is what I wrote here. So here are the new dimensions of the box: 4 by 4 by 7. So if the box is 4 by 4 by 7, right? Let's picture this part a second. If this is 4 inches, then what is the radius? Because it says the candles are cylindrical. Okay, they're in the shape of a cylinder. So what is going to be the radius of a candle that you put in there? The radius is going to be half of 4, which is 2 inches. All right, the radius of the candle has to be 2 inches. All right, so there's the formula to get the volume of a cylinder. Area of base times height. Area of base is pi times radius squared, and then times the height. So the radius is going to be 2 inches, and the height is going to be 7 inches. So when you multiply that and multiply it times pi as well, you're going to get approximately 87.96 cubic inches. Whoops. I meant to take out that sound effect. That was an accident. Whatever. Okay, now I'm going to go over a little bit more the topic of density, which is the chapter that we skipped. Okay, density is the amount of matter that an object has in a given unit of volume. The density of an object is calculated by dividing its mass by its volume. An easy way that I like to think about the what density is and what the formula is you could think about it this way. Density equals the amount of stuff in a certain amount of space, right? Density measures how much stuff fits in a certain amount of space. Okay, let's look at a couple of examples. And I'm putting these examples because we need to understand this for the next question that we're going to have on the test. All right, so here's our first example. A brick has a mass of 100 grams, right? This is the amount of stuff. And a volume of 50 cubic centimeters. This is the space. So all you got to do is divide those two to get the density of the brick. Mass divided by volume. So 100 grams divided by 50 cubic centimeters tells us that the brick has a mass of 2 grams per cubic centimeter. So for every cubic centimeter, you're going to have 2 grams of the brick. Here's another example. Jam in a jar has a mass of 91 grams and a volume of 65 cubic centimeters. What is its density? So again, here's the amount of stuff, and here's the amount of space that we're going to put it that it fits in. And we're trying to figure out how many grams would that be for every cubic centimeter. So when you divide the mass by the volume, you find the density, which tells you that it's 1.4 grams per cubic centimeter. Last example. Powdered sugar in a box has a mass of 100 grams and a volume of 200 cubic centimeters. What is its density? So again, divide the mass by the volume, and you're going to find that it has 0.5 grams of sugar per cubic centimeter. Okay, now let's go to the actual question that's on the test, which involves these formulas. All right, and I have it broken up into 3 different slides. It says an air conditioner manufacturer recommends that its portable units provide between 2 and 4 BTUs of cooling per cubic foot to operate most efficiently. Which of the following statements is true? A BTU is a British thermal unit. It is a measurement of energy. So we're going to use this formula for the question. Okay, and just to let me go over the question to make sure everybody understands it. Basically, there's a manufacturer of air conditioners, and they recommend that in order for the air conditioner to operate efficiently, the air conditioner unit needs to provide between 2 and 4 BTUs of cooling per cubic foot. Between 2 and 4 BTUs. That's the amount of cooling it has to provide per cubic foot in order to operate most efficiently. Now in the answers, they're going to give us several different scenarios, and we got to determine, is this statement true or false? Let me show you what I mean. Here's the first possible answer choice. Would a 10,000 BTU air conditioner meet the manufacturer's recommendation for a room measuring 20 feet by 40 feet with a standard 8-foot ceiling? Okay, let me do the first example so you can kind of get an idea what this is about, all right? First thing you're going to do is calculate the volume of the room. All right, the volume of the room is 20 by 40 by 8. So the volume of the room is 6,400 cubic feet. Okay, now the next thing I'm going to do is I'm going to translate how many BTUs would I need for a room of this size by making 2 proportions. All right, let me show you what I mean. All right, the minimum. Let me scratch this out for 1 second so you can see what I mean. Okay, so the manufacturer recommends that you have between 2 and 4 BTUs of cooling per cubic foot. Okay, so the minimum recommended by the manufacturer is 2 BTUs per 1 cubic foot. So I want to find out, what does that equal when you have 6,400 cubic feet? So I set up a proportion. 2 BTUs over 1 cubic foot equals how many BTUs over 6,400 cubic feet? All right, and when you solve that proportion, okay, you could do it 1 times what is 6,400? 1 times 6,400. So multiply the top times 6,400 to get what goes here. Another way you could do it is 2 times 6,400 divided by 1 equals what goes here. Anyways, when you solve that proportion, you're going to find that you would need a minimum of 12,800 BTUs. Okay, now let's find the maximum amount of BTUs that we would need in order to meet the manufacturer's recommendation by doing the same process, okay? Again, let me take this out for a second. It says the maximum BTUs that's recommended is 4 BTUs per cubic foot. So I set up a proportion, okay, 4 BTUs per cubic foot equals how many BTUs per 6,400? This should be a comma. 6,400 cubic feet. Okay, when I solve that proportion, I get 25,600 BTUs. Okay, so since we would need between this many BTUs for a room of this size, for a room that's 6,400 cubic feet, and we only have a 10,000 BTU air conditioner, that's not enough cooling power. Right? It's too low. We need something higher because we need between 12,800 BTUs and 25,600 BTUs. And this one only provides 10,000 BTUs. All right? Let's look at the second option. Would a 14,000 BTU air conditioner meet the manufacturer recommendation for a room measuring 20 feet by 20 feet with a standard 8-foot ceiling? So again, first calculate the volume of the room by multiplying the 3 dimensions of the room. So this room has a volume of 3,200 cubic feet. Now let's check what would the minimum BTUs be in order to meet the manufacturer's recommendation. I set up my proportion, and the minimum BTUs that I would need for a room of this size is 6,400 BTUs, and the maximum for a room of this size is 12,800 BTUs. Okay, does the 14,000 BTU air conditioner fall within that range? Yes or no? No, it does not. It's too powerful. It's more BTUs than required for this room. So this would also be false. This one does not meet the manufacturer's recommendation because it has too many BTUs. All right, let's check the third option. I meant to put 6A, B, and C here. I'll fix that later. Would a 5,000 BTU air conditioner meet the manufacturer recommendation for a room measuring 10 feet by 20 feet with a standard 8-foot ceiling? Okay, so first calculate the volume of the room. This room has 1,600 cubic feet. Now set up the proportion to check what would be the minimum BTUs that we would need for a room of this size. It's 3,200 BTUs. Now let's check the maximum BTUs for a room of this size. It's 6,400 BTUs. Does this air conditioner that's 5,000 BTUs fall within that range? Yes, it does. It's right inside that range. So yes, this one would meet the manufacturer's recommendation. So this would be the correct answer. This would be the true answer. All right. On the test, you're going to have 4 different answer choices, and you got to figure out which one is right by doing this process. All right, moving on. Amanda created a model of an ice cream cone by combining the shapes of a cone and a hemisphere. Based on the dimensions shown in the figure below, determine the volume of the model. So basically, we got to find the we got to find the volume of this composite figure, which consists of a hemisphere on the top and a cone on the bottom. So the first thing I'm going to do is find the volume of a hemisphere. Okay, and the formula for finding the volume of a hemisphere is the same as finding the volume of a sphere. The only difference is that a hemisphere is half of a sphere, so you got to add a 1/2 in the front of the formula for the volume of a sphere, which is what is right here. Okay, so the volume of this hemisphere, when you plug in the numbers, the radius is 6. Okay, and work that out. You're going to get 144 pi cubic centimeters. Now let's find the volume of the cone. The formula for volume of a cone is 1/3 of the area of the base times the height. So again, when you plug in the radius, which is 6, and the height of the cone, which is 8, you're going to get 96 pi cubic centimeters. Now to get the total volume of this composite figure, you just got to add the volume of the hemisphere plus the volume of the cone, and that'll give you your answer, 240 pi cubic centimeters. Number 8, the volume of a square-based pyramid is 4,275 cubic meters with a height of 18.9 meters. What is the length of each side of the square base to the nearest meter? Okay, so this problem is pretty straightforward. I'm going to use the formula to find the volume of a pyramid. All right, the formula for the volume of a pyramid is normally this. All right, 1/3 of the area of the base times the height. Let me rephrase that. This is the formula to find the volume of a pyramid. Now, if we have a rectangular pyramid, which a square is a type of rectangle, so if we have a rectangular pyramid, normally we would just write 1/3 of the area of the base would be length times width, and then times the height. Okay, but since we have a square-based pyramid, you got to realize that the two sides of a square have the same length. So that's why I wrote it like that, because the length and the width are going to be the same. So you should write it like that. We're going to need to write it like that in order to solve for how long each side of the square is. Okay, now from there, all you got to do is substitute the values that we have. We know the volume of the pyramid is 4,275 cubic meters, so that's why I wrote that here. And we know the height of the pyramid is 18.9 meters. All right, so we plug those in. Okay, now use your algebra skills to isolate the S. Okay, 1/3 of 18.9 is 6.3. Now divide by 6.3. And s to the second power is approximately 678.57. Now get the square root of 678.57, and that tells us that each side of the square of the base, each side of the square in the base of the pyramid is approximately 26 meters. That problem is pretty straightforward. The only thing is understanding this part, making sure you understand this part, and they're giving us the volume, so you're putting that into the formula. You just got to solve for S. Question number 9. Ariel is in charge of planting a peach orchid that covers 12 acres. He uses the same amount of ground space for each tree. Ariel plants 15 trees in the section of the orchid called the North Hill region that measures 420 feet by 35 feet. Approximately how many trees does Ariel plant in the orchid in all? 1 acre equals 43,560 square feet. Okay, so let me see if I could draw a picture to help us visualize this, all right? All right, so Ariel has a peach orchid that covers, the whole thing is 12 acres. All right, he uses the same amount of ground space for each tree. Ariel plants 15 trees in the section of the orchid called the North Hill region that measures 420 by 35 feet, all right? All right, so in this section called the North Hill region, he plants 15 trees. All right, so we got to figure out how many trees will it take to cover up the entire 12 acres. All right, so let me tell you my my strategy for solving this. All right, first thing I'm gonna do, which I'll show you in a second, I'm gonna translate 12 acres. I'm gonna convert. That's the word I was looking for. I'm gonna convert 12 acres into square feet. How am I gonna do that? It says right here that 1 acre equals 43,560 square feet. So all I gotta do is multiply 12 times 43,560 square feet, and that'll tell me how many square feet makes up 12 acres, or how many square feet is equal to 12 acres. All right, so once I change this to acres, once I change this to square feet, I could then divide by the area of this little rectangle here. The area would be 420 times 35, all right? I could then divide by the area of this rectangle. That'll tell me how many times this rectangle appears, in the 12 acres. And then whatever number that is, I multiply it times 15 trees, and that'll tell me how many trees I'll need to fill up the entire 12 acres. All right, hopefully that made sense, okay? So anyways, I got it all mapped out for you step by step. So the first step is to convert 12 acres to square feet. So since I set up a proportion, since 43,560 square feet is equal to 1 acre, I want to know how many acres, since 43,500 square feet is equal to 1 acre, I want to know how many square feet is equal to 12 acres. All right, so you could either multiply by 12, divide, and that'll give you this answer, or you could just think 1 times 12 is 12, so multiply this times 12 to get this. All right, in any case, this is the amount of square feet that make up 12 acres. Okay, now the next step, as I said, is to calculate the area of the North Hill region by multiplying 420 by 35. That's the rectangle, 420 by 35, all right? Multiply that, and that gives us the area of the North Hill region. That's where Ariel planted 15 trees. Okay, so once you have that, now divide the total square feet by the area of the North Hill region. And that tells us that, again, here's our 12 acres, which has been translated to 522 or converted to 522,720 square feet. That tells us that this little plot of land where Ariel planted 15 trees occurs 35.6 times within this entire plot of land. 35.6 times. So now I could multiply 35.6 times the 15 trees, and that tells us that I'm going to need about 534 trees, or Ariel's going to need approximately 534 trees to fill up the 12 acres. Again, you could just follow my step by step, and that'll lead you to the answer on the test. Okay, question number 10. Question number 10. The table, this one again involves, I have the formula right here, involves density. All right. This one's actually pretty easy. You just gotta do several calculations. All right. Okay, so it says, actually, let me just get my phone real quick. The table below shows the land area, the population, and the number of housing units in a country in 1950 and 1980. Determine whether each statement below is true or false. Okay, so remember, density is the amount of stuff in a certain amount of space. So, excuse me, in this question, you're going to be checking what's the population density and what's the density regarding the number of housing units in this space. Okay, so you know what? Let me just work them out before I even look at the answers. It'll help me explain everything, right? So first of all, let's check what's the population density in this land area in 1950. I do that by dividing the population, 157 million, whatever, by the 8.5 million square kilometers here. So let me divide that real quick. And I put those crazy numbers because that's how it is on the test. All right, you have some really long numbers. So when I divide that, all right, the population density is going to be 18.46. Approximately. All right, so I got that by dividing this number by this number right here. Okay, so that gives me 18.46. Let me do the same thing for 1980, the population density, 265,123,456 divided by 8,427,932. All right, and it gives me 31.5. You know what? Let me just change this into 18.5 and 31.5. All right, so this is the population density for each of these years. Now let's check the same thing for the number of housing units per every square kilometer. All right, all I'm doing is dividing this number by this number. All right, so 28,432,339 divided by 8,519,234. All right, so that's going to give me, let's say 3.3. That's the number of housing units per square kilometer in 1950. Now let me do the same thing for 1980 by dividing this number by the number of square kilometers. So 95,345,375 divided by 8,427,932 equals. All right, so this one is 11.3. All right, now let's look at the answers. The answer choices, I should say. Okay, so question 1. In 1950, there were approximately 18.5 people per square kilometer. That would be true. Okay, because that's the number I have right there, 18.5 people per square kilometer. Answer number 2. In 1980, there were approximately 3.3 housing units per square kilometer. Housing units. All right, so no, in 1980, the number of housing units per square kilometer is 11.3. So that would be false. Answer choice number 3. In 1980, the number of people per square kilometer was approximately 2.3 times the number of people per square kilometer in 1950. All right, so in order to check whether that's true or false, we got to divide 31.5 divided by 18.5 and see if that gives us 2.3. because it's saying 18.5 times 2.3 should equal 31.5. All right, so when I divide that, 31.5 divided by 18.5, I get 1.7. So when I divide that, I get 1.7. And right here it says that it's supposed to be 2.3 times. 18.5 times 2.3 is supposed to give you this. So that would be false. That question is false. Great, I just deleted my answers. All right, and I think it was 18.5 and 31.5, I think. All right, I'm pretty sure it was that. In 1980, the number of housing units per square kilometer was approximately 3.4 times the number of housing units per square kilometer in 1950. Okay, great, I deleted the, all right, let me just get it real quick. 28,432. All right, this number was 3.3. And the other one was, one second. This is what happens when you're rushing. I'm actually recording this at like literally 6 in the morning, trying to get it done for first block. All right, this one was 11.3. All right, so it says in 1980 the number of housing units per square kilometer was approximately 3.4 times. All right, so to check whether this is 3.4 times that, I got to divide 11.3 divided by 3.3. All right, and that is going to be true. That is true. All right. Now listen, just because these are my answers on the review doesn't mean that these are the same answers on the test. I purposely mix it up and change things up. So on the test, you got to work every single one out to check which one is true and which one is false. All right, question 11. A bottling company makes decorative bottles and ships them to their customers. Each bottle has a height of 8 inches and a radius of 1.5 inches. The manufacturer places each bottle in cylinder packaging and adds cushioning to the insides of the cylinder. The cushioning is an inch thick on each side of the bottle. If the height of the cylinder is the same height, let me read that again. If the height of the cylinder is the same as the height of the bottle, what is the volume of the cylinder used to package the bottles? Okay, this problem is very similar to, I think it was example number 5. There's only one difference, and that difference, I underlined it right here. It's a very important difference, which changes part of my solution. All right. The difference is that here, it says that the height of the cylinder is the same as the height of the bottle. The cylinder is the packaging, all right? You're putting these bottles in a package, and in this case, the package is in the shape of a cylinder. So if the cylinder and the bottle that you're putting inside are the same height, that means that you cannot add, okay, that's my bottle. That means that you cannot add the cushioning on the top and on the bottom. All right, so the height of the bottle and the cylinder are going to stay the same. The cushioning only goes on the sides, not on the top and on the bottom. That's the difference between this one and question number 5, I think it was. On that one, there was cushioning on the top and on the bottom, which made the height smaller. Okay, so the cushioning adds an inch to the radius. All right, so the radius of is now 2.5 inches. All right, because hold on, I'm just rereading the question. All right, because the question is, what is the volume of the cylinder packaging? This is the package, not the bottle. What is the volume of the cylinder used to package the bottles? All right, so they're giving us the dimensions of the bottle. They're giving us the dimensions of the bottle. The bottle has a height of 8 inches, which is not going to change, and a radius of 1.5 inches. So if you're adding cushioning on each side of the bottle, and that cushioning is an inch thick on each side of the bottle, okay, that means that the radius is going to grow by 1 inch. The radius is going to be 1 inch bigger than what it says here. The radius is now going to be 2.5 inches. All right, you may have to think about that in order to imagine it. Look, I'll try to draw. Here's a bottle, a badly drawn bottle. Okay, so the radius, it came out better than I thought. The radius of the bottle is 1.5 inches, right? But they're gonna add cushioning on the side of the bottle. That's the cushioning. Okay, and the cushioning is 1 inch thick on each side. All right, this is 1 inch, and this is 1 inch. So if you think about it in terms of the diameter, which is the entire line, okay, that would be, you're adding 2 inches. Okay, but if you think about it in terms of the radius, you're adding 1 inch to the radius, so that's why the radius is becoming 2.5 inches. All right, and that's it. Once you know that, you can figure out the rest pretty easily. Okay, the height is the same for both the bottle and the cylinder packaging. So now I'm going to get the volume of a cylinder using the formula for volume of a cylinder, which is area of base times height. The area of the base is pi times radius squared. We know that the radius is 2.5. The height of the bottle is 8. And they want us to use 3. It says in the question they want us to use 3.14 for pi. So now just work that out, and your answer will be 157 cubic inches. All right. Okay, question number 12. Johnny's camping tent is in the shape of a triangular prism. He wants to reinforce the fabric of his tent with a waterproofing treatment. Find the total surface area, including the floor, of Johnny's tent shown below. Round your answer to the nearest square foot. All right, so we got to find the surface area of this triangular prism. And the only curveball that you got to watch out for is that, let me see if I put it here. Okay, remember that to find the surface area, first we got to find the lateral area, which is the perimeter of the base times the height. All right, the perimeter of the base is this triangle. But to find the perimeter of the base, I need to know how much is these sides, how long are these sides. And in order to do that, I'm going to need to use the Pythagorean theorem right here to figure out how long this side is. All right. So you have a right triangle here where this side is 4 feet. And this side right here is going to be half of this side. This entire side is 5 feet, so this side has to be 2.5 feet. So you're going to have to use the Pythagorean theorem to find how long is this side, the hypotenuse, which is this side right here. All right, so when you do that, you're going to find that the, well, I didn't write what you get here, okay, but the perimeter of the base is going to end up being 14.4. All right, the perimeter of the base. If you don't look at this video ahead of time and you're just going to look at my PowerPoint, you're going to be like, where did he get the 14.4 from? And I'm going to tell you, you know what? You should have looked at the video. All right? But that's how the 14.4 is the perimeter of the base. Once I got this number, once I got whatever this is, this side is going to be the same as this side. All right? So whatever number you get for this side, it's the same on this side. And then you add this one plus the 5. To get the perimeter of the base. Actually, I could tell you right now what it was. If the perimeter of the base is 14.4, just subtract 5. You're going to get 9.4, and then divide 9.4 by 2. All right, so it's going to be 4.7. All right, this side was 4.7, and this side was 4.7 when I did the Pythagorean theorem. All right, so I added 4.7 plus 4.7 plus 5 to get the perimeter of the base, which is 14.4. And now you multiply that times the height of the triangular prism, which is 8. So the lateral area of the triangular prism is 115.2. Now let's get the let's get the surface area by adding the lateral area plus 2 times the area of the base. Okay, so the lateral area we already established is 115.2. That's what this is. And then 2 times the area of the base. 2 times, remember the area of the base is the triangle. So to get the area of a triangle, you do 1/2 of the base times the height. 1/2 of 5 times 4, which will give you 10. And since there's 2 bases, this one and this one back here, all right, that's why we're multiplying it times 2. So the final surface area of the triangular prism is 135.2 square feet. Okay, this brings us to our last problem for section 2 for the review. And I got to tell you, this problem is a bit of a monster. If you thought the other ones were a lot of work, this one is a bit of a monster. And it's on the test. All right, so I laid it out step by step, but it's quite a bit of work. All right, it says, first of all, let's go through the question and make sure you understand what the question is. Store Trash manufactures trash cans that are open at the top and do not have lids. All right, so that's important. The trash cans do not have lids. That's why I underlined it. Okay. The reason it's important is because not at the beginning, but towards the end of the problem, we're gonna have to find the surface area of these trash cans, and if they don't have lids, that means that we're not finding the surface area for the top. We're leaving that out. The top base in both of them, we're gonna leave it out when we find the surface area. Anyways, the company's engineers are designing a trash can that has a total volume of 4.71 cubic feet. I wrote that here. This is the total volume for both trash cans because it says the company engineers are designing a trash can that has a total volume of 4.71 cubic feet for both of them. They are deciding between a rectangular prism-shaped trash can with a base dimension of 2 feet by 1 feet and a cylindrical trash can with a base area of 3.14 cubic feet. 3.14 square feet. The material used to manufacture the trash cans costs $3.50 per square foot. Which trash can design will cost the company less to manufacture and by approximately how much? All right. So let me try to guide you through this, all right? First thing you should do is we got to find the height of these prisms. We got to find the height of these prisms. And the way we're going to find the height is by using the volume, all right? Since the volume is 4.71 cubic feet, and the formula for both of them is area of base times height, all you got to do is 4.71 divided by the area of the base, and that'll tell us the height of each of these prisms. All right. The area of the base for this rectangular prism would just be 2 times 1. So that's the area of the base for this one is 2 square feet. And the area of the base for this cylinder, they already gave it to us. The area of the base is 3.14 square feet. All right, so I have it all worked out here, right? So first, I underlined the steps. First, find the height of the rectangular prism. Okay, so since volume equals the area of the base times the height, and we already know the volume is 4.71 cubic feet, and the area of the base would be 2 times 1, which is 2. That's what that is right there. So divide 4.71 by 2, and that tells us the height of this rectangular prism. The height is 2.355 feet. That's the height. Okay, and then the next step is to just find the surface area. Okay, because we're trying to find out. I'm just reading the question. The material used to manufacture the trash can. Okay, so the material used to manufacture this trash can is going to cover the surface area. It's going to consist of the surface area of this trash can for everything except the top part because it has no lid. So basically, we got to find the surface area of this rectangular prism and leave out the top base. And that's what I'm doing here. I'm finding the surface area of the rectangular prism. First, I get the lateral area, which is the perimeter of the base times the height. The perimeter of the base is 6, and the height is 2.355. The lateral area is 14.13. And then, for the final step, I don't do 2 times the area of the base because the base, we're only going to need it 1 time. So I leave the 2 out. I just do lateral area plus base. And that gives me the surface area of the rectangular prism. And if I want to know how much it's going to cost, I just multiply the surface area of the rectangular prism times the cost per square foot, which is 3.50. And that tells me that the cost is going to be $56.46 for the rectangular trash can. Okay, now I'm gonna do the same process for the cylinder, for the cylindrical trash can. First I find, excuse me, first I find the height of the cylinder, okay, the same way I did it over here. Okay, now one thing I want to point out real quick before I continue. You know how they gave us the area of the base for this one, and they said that the area of the base is 3.14 square feet? What does that tell us about the radius? What does that tell us about the radius of this circle? Okay, to get the area of a circle, we do pi times radius squared. So if the area of this circle is 3.14, and we know that pi equals 3.14, right? Then what does the radius have to be so that when I multiply it times 3.14, I get 3.14? Obviously, the radius would have to be 1. The radius is 1 because 1 to the second power is 1, and 1 times 3.14 would equal 3.14. Okay, listen, since this problem is hard enough as it is, I'm telling you right now, on the test, the area of the base is also 3.14. So on the test for this problem, the radius of this cylinder will also be 1. All right, I'm giving you that because this problem involves enough calculations as it is. And you need to know that the radius is 1 because we're going to use it over here to find the surface area of a cylinder. So again, on the test, the area of this cylinder, the area of the base for this cylinder is also 3.14, which means that the radius of this circle is 1. It's like that on the test. Alright, so again, first thing I did is find the height of the cylinder, alright, by using the volume of the cylinder and the area of the base. That allows me to solve for height, which is 1.5 feet. For this cylinder, the height is 1.5 feet. Now, all I got to do is find the surface area of the cylinder, but you got to remember to leave out the base at the top because it does not have a lid. Alright, so first I find the lateral area by doing 2 times pi times radius times height. 2 times pi times radius is just the circumference of this circle. Alright, when I work that out, the lateral area of the cylinder is 3 pi. And then the area of the base on the bottom is 3.14. I add those two, well, I multiply 3 times pi, and whatever that gave me, I add it with 3.14. And that gives me the surface area of the cylinder, which is 12.56 square feet. I multiply 12.56 square feet by $3.50 to get the cost of making that cylindrical trash can. So now we can compare the cost of making the rectangular trash can versus the cylindrical trash can and see that the cylinder one is cheaper. And the question asked by how much? By approximately how much? So subtract those two numbers. All right, subtract 56.46 minus 43.96, and that'll tell you by how much is it cheaper. In this case, it's cheaper by $12.50 to manufacture a cylindrical trash can. All right. Again, this is the type of question you got to look at it ahead of time. If you're trying to figure all that out, if you're looking at that for the first time while you're doing the test, you're just going to end up guessing because there's just too much information, too much to do, and you're going to panic and just guess. All right, so you definitely, section 2 is something that you definitely need to look at ahead of time and study it ahead of time. All right, because despite all this help, if you don't know what you're doing, you're still going to do bad on it. All right, guys, that's it for the review for section 2. Hope you guys have a great rest of your day, and I'll see you guys next class.